So here we are presented with a compound fraction that looks a bit different from the one we did in the previous video. Now if you observe this compound fraction very well, you see that the denominators are not linear. Remember the ones we did, we solved for linear denominators, and in this case now we are unable to factorize this denominator. You check it with the discriminant, you see that the discriminant of this, you take the square root, it's not a whole number. So because of this factor here, which is not a linear polynomial, our approach to resolving this problem will be slightly different from what we did initially. Now this is a linear factor, right? We follow it the same way, but this is not a linear factor. This is polynomial of degree 2. So how do we approach it? We approach it by saying this. So we say that this polynomial, this compound fraction will give us a partial fraction that is of this form: a over this factor. The highest power of x, the numerator, must always be at least less than the highest power of x in the denominator, right? So for this case of this quadratic factor, so we have something like this: this plus bx plus c over x squared plus 5x plus 1. So this is how the partial fraction for this compound fraction will likely look at. Observe, we have x here because we are trying to mimic the possible partial fraction that will sum up to give us this, right? So because we have the highest power of x here as 2, so we are saying if we are to get the partial fraction, it will be at most x raised to the power 1 here. If I will have the x here as x raised to the power 3, we are going to write our possible partial fraction as something of this form: bx squared plus cx plus d. That is if we have something like x raised to the power 3 here. So this is how we follow it. We always present it. We are like setting it and say this is how it may look like. So let's solve and see what I mean on this explanation. So from here we'll go through the same approach now. So we have 2x squared minus 3x plus 1 over x plus 1 x squared plus 5x plus 1. I'll say that this is equal to the same way we did it before. A, that's when we take the LCM, x squared plus 5x plus 1 multiplying bx plus c times x plus 1. This is over x plus 1 x squared plus 5x plus 1. So we have multiplied it. The LCM of these two things is this. I'll say this divided by this, you are left with only this one. So we multiply it, a times this, and this factor times this one. So that's how we follow. So now let's open up this bracket and compare coefficients. It is exactly the same process. The only difference is that when you have the denominator, when it's not linear, you set the partial fraction to mimic the possible solution. Is that clear? Yes. So let's proceed further. So from here we have 2x squared minus 3x plus 1. I'll say that is equal to, open up the bracket, you have ax squared plus 5ax plus a. Then this one will have plus bx squared plus bx plus cx plus c. So this is over the denominators. You can choose to write it again. Okay, let's just say x plus 1 x squared plus 5x plus 1 over x plus 1 x squared plus 5x plus 1. Now we have gotten to this point. Now this is the most interesting part. So from here we can compare coefficients. If you observe, the coefficient of x squared here is what? 2. Now what's the coefficient of x squared from this place? You see that the coefficient of x squared was a plus b. So from here we have a plus b x squared, right? 2x squared minus 3x plus 1. We have a plus b. We are collecting like things now. Plus 5a plus b plus c. X. These are the coefficients of x. Right? When we collect 5a B, C, right? Then the constant term, that is A and C. A plus C will give us what? A plus C is equal to 1. No, A plus C, like this. So now we proceed to compare coefficients. So from here we see that A plus B, since these two things are equal, their coefficients are also equal. A plus B will be equal to what? 2, right? So 5A plus B plus C will be equal to what? Minus 3, because the coefficient of x here is minus 3. The coefficient of x here is 5A plus B plus C, right? So here we say 5A plus B plus C equal to minus 3. Then finally we say A plus C equal to 1. So we proceed to solve this simultaneous linear equation, and we are going to be using the method of substitution here. So because of our space, we had to clean, and these are the 3 simultaneous equations we got by comparing coefficients of that. So from here now we are going to solve this linear equation simultaneously. So we can go by the method of substitution. If we go by substitution, we can use this equation 3 and make C the subject. So we see that C is equal to 1 minus A, right? So we substitute this value of C in this equation 2. So we sub C in 2. So this 3, this 2, this 1. So when we substitute A, C here, we have 5A plus B plus C now be what? 1 minus A, which is equal to minus 3. So we have here as this minus this is what? 4A. 4A plus B will give us what? When this one cross, we have minus 3 minus 1, which is what? Minus 4. So we have 4A as what? Minus 4. That is 4A plus B is equal to minus 4. So if you look, you see that from equation 1 we have A plus B. From this equation 2 we have 4A plus B. So we can solve this two now by elimination to get rid of what? B, right? So let's solve it here. So from here we'll say A plus B equal to 2 and 4A plus B equal to minus 4. So we subtract them. When A minus 4A will give us minus 3A. This minus this will go 2 minus 4. 2 minus 4 will give us what? 2 plus 4, which is what? 6. So if we divide through by minus 3, we have that A equal to minus 2, right? A is minus 2. So if we substitute A as minus 2 here, see that B is equal to 2 minus A, right? So we have here as B equal to 2 minus 2, which is say 2 plus 2, which is 4. So we now have the value of B as 4 and the value of A as minus 2. So if we come back to this our equation here, we can easily get the value of C because we already know the value of A now. So we say C equals to 1 minus A. C equal to 1 minus A. But A is what? Minus 2. So C will be equal to 1 minus 2. So have that C equals to 1 plus 2, which is equal to what? 3. So I've gotten the value of A as minus 2. Got the value of B as 4, got the value of C as 3. So bring these values here and fix them in this arbitrary constant. So fix these values here, and that's our partial fraction for this compound fraction here. With the value of A, B and C gotten, we can proceed and say 2x squared minus 3x plus 1, which is the compound fraction, x plus 1, x squared plus 5x plus 1. That is equal to, we got the value of A as what? Minus 2. So we have minus 2 over x plus 1 plus, we got the value of B as 4. So say 4x and the value of C as 3 plus 3 over x squared plus 5x plus 1. So this is the partial fraction for this compound fraction. So we can, as usual, we can go ahead to verify if this is actually correct, because we say that resolution of partial fraction means writing a compound fraction as the sum of partial fractions. So if we sum up these two things, are we going to get this? Let's work it out together. So we can actually proceed to verify if this is actually the correct solution to this, like we did in the previous video. So we can see from here that when we take the LCM from here, and we have that minus 2 brackets x squared plus 5x plus 1 plus this one will be 4x plus 3. Then here we have x plus 1. So this is over x plus 1 x squared plus 5x plus 1. So let's just evaluate the numerator, since we have seen that the denominators are the same and we have already taken the LCM. Let's evaluate this numerator since we are just trying to verify. So when we open up the bracket, we have minus 2x squared minus 10x plus, here we have minus 2, then we are done with this one. So here we have this time, this will give us plus 4x plus 4. We are done with this now. This one will be plus 3x plus 3. So this is 4x squared. So when we collect the like terms now, we say that this and this are x squared. We collect the like terms, so we have 2x squared minus 10 plus 4x plus 3x will give us minus 3x. Then we are done with this. Okay, let's just, we are done with this. So this and this will give us what? Plus 1. So that this is over x plus 1 x squared plus 5x plus 1. So that this, when we sum up this thing, we still get back this our compound fraction we started with. So this verifies that this is actually the partial fraction that comes from this. So this is just how to resolve non-linear polynomial denominator. So we have non-linear polynomial as the denominator of the compound fraction. This is just the step of how to resolve it. So let's see another example and see that it is the same step, the same process. So in this problem here, we have to resolve this compound fraction into partial fraction. So the same step, the same process, nothing changed. So when you observe from here, we see that we have a polynomial denominator here, right? And it is not linear. So you follow the same. Even if you have only x squared here, you still follow the same process. As far as the highest power of x there is more than 1, you must follow the same process of saying a over x minus 2 is for this linear. That's why we have only a here. Since this one is not a linear, you follow it judiciously. Bx plus c over x squared plus 5. I told you, if we have x3 here, we're going to have something. If we have x3 here, we're going to have something like x squared plus cx plus d. If you have x4 as denominator, we're going to have bx to the power of 3 plus cx to the power of 2 plus d to the power of 1 plus e. That's the rule, because we are trying to mimic the possible partial fraction, and the resolution means find those arbitrary constants a, b, c, and d and substitute back there. That's the partial fraction. Thank you very much. So let's proceed. So from here we can see that 3 over x minus 2 x squared plus 5, that this is equal to, when we multiply, we have a into x squared plus 5 plus x minus 2 times bx plus c, and this over x minus 2 x squared plus 5. So from here now we can proceed to open the brackets, collect like terms and compare coefficients as we did in the previous one. So here we have a x squared plus 5a plus x multiplied through, we have b x squared plus cx minus 2bx minus 2c. This is equal to 3 over x minus 2 x squared plus 5. The same thing we have here, x minus 2 x squared plus 5. So now we collect coefficients, right? We collect like terms. So collecting like terms here, you see this and this are like terms. So a plus b, this and this are collecting like terms. X squared plus this 5a, let's just write it, this c x, this, so we have plus c minus 2b x, right? These are their c and 2b are coefficients of x, so we write them, then the constants, plus 5a minus 2c. So this is equal to 3 over x minus 2 x squared plus 5 over x minus 2 x squared plus 5. Now we are about to compare coefficients. I know you may be confused. How do we compare coefficients? Here we have only 3, and here we have x squared, we have x, we have, it doesn't matter. Here we have only 3, which you can see, but every other value of the polynomial, they are still there, just that their coefficients are 0. Like here now we have 3. This thing is 0x squared plus 0x plus 3. That's what this 3 means here. So if we compare coefficients, that the coefficient of x squared here is a plus b. The coefficient of x squared is what? 0. So we say a plus b equal to 0, right? So the same thing happened here. C minus 2b is the coefficient of x here, and the coefficient of x here is what? 0. So we are comparing the coefficients. We say that c minus 2b equal to 0. So we also say c equal to what? 2b. Then here we say 5a minus 2c is equal to what? 3, because they are the constant. This one is the coefficient of x raised to power 0, which is 1. Is that clear? So you can pause the video and rewind what I just said so that you can get the concept very, very well. So let's proceed further to completing this. So with that being said, we have that a plus b equal to 0. That means a equals to minus b. And here we have that c minus 2b is equal to 0, which implies that what? C equal to 2b. Then from here we have that 5a minus 2c is equal to 3. So we can proceed to solving these 3 simultaneous equations, this, and this. So from here we can easily substitute the value of a here, then take that value and put it here. So here we can say that b is also equal to what? Minus a, right? So we say that this implies that c is equal to minus 2a, because here we, since a equals to minus b, that means b is equal to what? Minus a. So we have that c equal to minus 2a. So if we take that value of c equals to minus 2a and bring it here, so I have that 5a is equal to, okay, 5a minus 2 multiplying what? Minus 2a is equal to 3. So here we see that this is what? 9a. So I have that 9a is equal to 3. So a is equal to what? 3 over 9, which is equal to 1 over 3. So I've gotten the value of a as 1 over 3. Let's just wipe here and finish up the other. From here we saw that a is equal to 1 over 3, but b is equal to minus a. Therefore b is equal to minus 1 over 3, and c is equal to 2b, right? C equal to 2b, implying that c equal to minus 2 over 3. So I've gotten the value of a 1 over 3, b minus 3 over minus 1 over 3, and c minus 2 over 3. So we can proceed to substitute here, and that's our partial fraction. So when we substitute this value here, we have that a is what? 1 over 3, right? A is 1 over 3. So having 1 over 3 into x minus 2 plus b is what? Minus 1. So we're having minus 1x over 3. Then c is what? Minus 2 over 3. This over x squared plus 5. So if we want to write this thing properly now, we have that this is equal to 1 over 3 into x minus 2 minus x plus 2 over 3 into x squared plus 5. So this is the partial fraction for this compound fraction. So you can proceed to verify it, right? You can just proceed, pause the video and verify if this is actually a correct solution. You know how to do it. You take the LCM of this and you cross multiply and see that it's going to give you this particular compound fraction here. to show that this is actually the solution for this problem. Let's look at one more example on this case of partial fraction. Here we have this compound fraction 10x squared plus x plus 9 over x into 2x squared plus 3. So to resolve it to partial fraction, the same step, the same process. So it's equal to a over x, because this x is linear, plus bx plus c over 2x squared plus 3, because this denominator here cannot be factorized into linear factor. That's why we have it this way. So we proceed to solving. So we have 10x squared here plus x plus 9 over x into 2x squared plus 3. So this is equal to a into 2x squared plus 3 plus x into bx plus c. This over x into 2x squared plus 3. Right, so we open all the brackets. Okay. So have 2a x squared plus 3a plus bx squared plus cx. This is equal to 10x squared plus x plus 9. So we compare coefficients, this and this. So we have 2a plus b x plus cx plus 3a is equal to 10x squared plus x plus 9. When we compare coefficients here, we see that this is equal to what? 10. So how that 2a plus b equal to what? 10. We compare coefficients, we see that the coefficient of x here is what? 1. The coefficient of x here is what? C, only c. So we just clearly have that c is equal to what? 1. Very simple. So here we have that 3a is equal to what? 9. So 3a equal to 9. You can easily divide and see that a is equal to what? 3. Right, so we are left with getting the value of b. Since I've gotten a as 3, you can easily substitute here, because b is equal to 10 minus 2a. So say b equal to 10 minus 2 into 3. So b equal to 10 minus 6, which is equal to what? 4. So I have the value of a as 3, the value of b as 4, and the value of c as what? 1. So we substitute it here, right? So when we substitute the value of a, we have 3 over x plus 4x plus 1 over 2x squared plus 3. So this is the partial fraction for this. 10x squared plus x plus 9 over x into 2x squared plus 3. So we can proceed to verify. Right, one interesting thing about this is that you can always know when you are wrong or when you are right. So let's check if we are right. So when we do the same process, we have here as well 3 into 2x squared plus 3 plus x into 4x plus 1. So let's not care much about the denominator. Let's just quickly. So this and this, we have what? 6x squared. This multiply this, we have plus 9. This one open up, we have plus 4x squared plus x. So when we collect like term from here, this and this are like term. So here we have 10x squared. We don't have any other x except this. So say here as plus x, then plus 9. So that this is same thing as what we have here. So this verify that this is actually our solution. Right. So let's just one last example. If you have followed this tutorial video up to this point, I believe you should be able to solve partial fraction on this form when the denominator is not linear. So I want you to pause this video and attempt this question here. It's just the same way. First thing you have to do is to multiply this polynomial up, this linear factor up, multiply it so that you have a quadratic polynomial. When you multiply it, you have x squared minus 1, right? Then you resolve it with the same method, and I'll be waiting to see your answer in the comment below. If you have any difficulty solving it, I'm going to help you out. So in this video here, we talked about when you have repeated linear factors, let's say you have one of the factors on the denominator as x squared plus 1 is of something like this. How do you approach it? Have a partial fraction like this, x minus 1 and this, something like this. How do you arrange this denominator into partial fraction? So I'll see in that video. Thank you very much for watching. Please subscribe.